All right, and we should be live. So I just want to check my audio. How are we on YouTube? Let me just check. Yeah, okay, we should be good. The audio seems to be fine. Okay, let's 1 2 1 2. Yeah, okay, we're good. Right, let's continue. Right. So yesterday we covered what did we cover yesterday? Yesterday we covered if statements, booleans, fixed width integers, fast and long integers, size of, standard size suffix t, scientific notation, i.e. Moving the decimal points to the left or right and plus or minus after e, floating points, float, double, long doubles, not a number, infinity, booleans, and if statements. So today we're going to finish off the data types, and we're going to continue with characters. Okay, let's get started. That's that. So previously we've done characters. Yeah, so previously we've done characters of single characters, but is that the right? Is that where we actually left off? 4.4.11. Yeah, it is. Okay. So characters. Okay, cool. To this point, the fundamental data types we've looked at have been used to hold numbers or true or false values. And also last lesson, or last stream rather, we learnt about integral types as well. That was they're very important. But what if we want to store letters or punctuation? So consider this code. We include the input-output stream. We have a return type of main. We have a standard character output of would you like a burrito, yes or no. We want the user to enter yes or no. How do we do this? The character type was assigned. Let me just add some notes. Chars. And then we'll do double that. A character can be a single letter, number, symbol, or white space. The character type data, also if you are enjoying these streams, please comment what you're enjoying and what you would like me to improve on, and always like, comment, subscribe, and all that good stuff. Anyway, now that's out of the way, let's focus on what we came for. The character data type is as an integral type, meaning the underlying value stored as an integer. Okay. The char data type is an integral type. This means that it is actually stored as a integer. Okay, interesting. Similar to how a Boolean, how we had false being 0 and 1 being true. 0 being false and a non-zero being being true. The integer is stored and represented as an ASCII character. So when the char is stored, it is represented as an ASCII character. Okay. And that stands for American Standard Code of Informational Exchange. Excuse me. And defines a particular way to represent English characters, plus a few other symbols. So between 0 and 127. So does that mean that a character is the range of 8? It's either 8 bytes, isn't it? No, 4 bytes because so it's unassigned, right? What was the range? We did it. Yeah, sorry, 8 bits, not bytes. Unassigned, I assume that means. Or maybe I'm just making that up. For example, the 97 is interpreted as A. Okay, that's interesting. And then character literals are always placed between single quotes. Okay. So it defines a particular way to represent. Cool. Okay. So you got all the various ones here. Whoops. That's much better. What I'll do then is get rid of this, get rid of this. Can I screenshot that? Just about. No, I think what would be best is if I did this. No. Can I zoom out? Yes, I can. Okay, if I screenshot that, because I don't really want to write all that, and then I do that, and I can save it for later. Okay. No thanks. And I'll just reset it to normal. So there you got 127. Codes 0 through to 31 and 127 are called unprintable characters. So 0 through to 31. Oh, these ones. Sorry, my bad. These ones. These codes were designed to control peripheral devices such as printers. Many are obsolete. Codes 32. So from space to 126, squiggly line are printable characters. And then the final one is delete. Obviously, they're unprintable. If you print character outside the range, the result will depend on your OS. Initializing chars. You can initialize a char variable using char literals. So we've initialized char with C2A. Um, and then we initialize it with A. You can initialize chars with integers as well, but it should be avoided when possible. Be careful, do not mix up chars with integer numbers. The following two are not the same. So that's stored as an integer, and that is stored as a code point for 5, um, a hard coded 5 printing characters. When using standard character output to print a char, standard character output prints the variable as a ASCII. My bad, that should have quotations. Single quotes because it's only one character. So this would print A. This would still print A. This would print B. And this would print B as well because C2 is 98 and the code for B is 98. So it would print AB. Cool. We can also output chars directly. This produces C. Inputting chars. The following program asks the user to input a character, then prints out the character. Input a keyboard character, so we've got an uninitialized char. We then ask the user via the insertion operator to enter char, ch, and then you entered, here's one output, q. Note that cin will let you enter multiple, however, can only hold one character. Consequently, only the first output character is extracted. This results in the input being left out. Yeah. So we got enter a keyboard, char, ch, c. Standard character output, ch. Note the following that it grabs the key. Okay, so if you are asking the user to enter a character, through C, a character in it, and then produce an output, it will only produce /output/print one char. The others are kept in a queue. So then what you could do is you could yeah. So then if you did another cin, the output would then grab the queued input, such as this. I won't copy and paste because I understand this. Okay. If you want to read more characters than one char, you need to use a string. A string is a collection of sequential characters. We'll discuss this in a later lesson. Extracting white space characters. So I do know that in other OS systems such as iOS or Swift rather, you can use ignores white space, something like that, and then you would do or replace white space, and then you would have the quotation marks with a space in between, and then replace it with quotation marks without a space in between. But that's for strings, but we're dealing with characters at the moment. Because extracting input ignores leading white spaces, this can result in unexpected results. So import character, uninitialized, character input of that, you entered that. So it will still be A and B. So one simple way to address this, I feel like I should make a note of this, extracting white space chars. Okay. And these are more. So then one way to address this issue is to use standard cin dot get function to perform extraction instead, as the function does not ignore leading white spaces. So I just want to, because I've never used .get for that, I want to actually now copy that, because the best way to learn is to keep practicing. IOStream will have a return type of integer for our main function. We'll then ask the user to input a keyboard character, and then we'll initialize or create the variable but have it uninitialized. So char ch uninitialized will allow the user to enter said integer. So it said char. We'll then have a standard character output of we'll then have a standard character output of .get. No, we won't. We will have a standard character input, and then instead of the insertion operator, we'll do .get, and then we'll have ch. Is that right? Yeah. Then we'll have the standard character output of you entered, and then another extraction operator, and then ch, and then we'll have a line break. Then we will extract the next one. So character in. So std character in dot get, and then again we'll be putting in the parameter or the argument of ch, and then std character output of extraction you also entered, and then ch, and then a line break. And then we will return 0. That all good? We'll then run that in our terminal, and we'll just do the same as what he did there. So we'll do A space B. You also entered. We'll just do that. So we'll do that again. We'll do A space B, yada yada yada. Cool. And I assume if we did that again, we would get B, right? So A space B. Yeah, cool. So that means that essentially means that what does it mean? Means that the std character in dot get loads the queued characters, and then allows the standard character output to call / show them. So a jar is 1 byte, aka 8 bits. So a char is 1 byte, aka 8 bits, although usually signed. Okay. Escape sequences. There are some sequences of characters in C++ that have special meaning. Escape sequences, such as a line break. And you can have them, as we've learned previously, on one line or within the output. Another one is T, another company which embeds a horizontal tab. Escape sequences. Okay. We know that is a line break. We can also use T to embed a horizontal tab, such as the following. And because I've never done this before, I will code it myself before we see what the output is. So include your input-output stream. We'll have a return type of integer for main. We will then have the body, and we will have a standard character output of first part. Then straight after part we'll have the t, \t, not /, and then we'll have second part, and then we will return 0. Now let's clear our terminal and let's see what we get. Okay, so there we get a horizontal tab, i.e. as if we did this. Yeah. I.e. as if we pressed tab on our keyboard. Yeah. Other notable escape sequences are / single quote which prints a single quote, / double quote prints a double quote, and finally \\\\/ prints a \\\/ and then we'll just make a screenshot of that just for future reference. Okay. So you got alert, makes an alert such as a beep. You got backspace, B moves the cursor back a space. Form feed moves the cursor to the next logical page. New line, as we've done. Carriage return moves the cursor to the beginning of the line. Horizontal tab we did. Vertical tab we did. Vertical tab would just, I assume, move to the next line. Single quote we did. Double quote we just did. \, question mark, octal number, and then hex number. And then if you'd like to follow along, you can just do that. Escape sequences start with a \, not a /. So it must be noted that escape sequences, and then we'll do that. We learned last time that, or we learned in lesson 1.5, that it's preferred to use \n rather than standard character or standard n line, because n line is buffering and can cause issues. What's the difference between putting symbol in single quotes versus double quotes? For example, A is represented by the character A. Single quote characters usually should be quoted, single quote quoted, rather than double. That makes sense to me. Avoid multiple line literals. Is supported. Okay. Multiple line character support often causes problems for new programmers when they forget whether their escape sequences should. Okay, yeah, so that should not be, that should be a backslash. The issue here is that they use it forward slash. Make sure that okay, that your new lines are like that. Okay, here's another example. So you got an integer of x being assigned as, that's annoying. You got an integer of x with a assignment of 5. Standard character output x is a value of 5, but we have a backslash, so that should work, right? Yes. But the output isn't nearly exciting enough, so we decided to put an exclamation mark before the new point. So you got the same thing, but with a exclamation mark. Okay. So in that case, what I think you would need to do is you need to make this double quote. And you get a weird value. Using double quotes exactly either makes the kind of issue easier or avoids them entirely. Because if you use a double quote here, you would get just the exclamation mark. And to prove it, let's just do it. New body, and we'll do int, and we'll assign int with 5, and then we'll do a standard character output, extraction operators, and then we will do, what will we do? We do the value of x is x, and then we'll do double quotes, and then a line break, and then return 0. And we should find that we actually get the correct exclamation mark. There you go. Cool. And then other types. Okay. Let's move on to the next lesson. The final one before the summary and test, I think. So, implicit type conversion. So let's see what this does. So you got a include IO stream library. You take a double parameter in a void function, standard character output of x, print 5. What happens when we pass in an int? We would get an error, would we? Let's actually see what happens. So you got a void type of print with a double of x, and then we would do standard character output of x, then with a line break. Then we have our main integer with the return type of int, and we are printing 5. But you can see here it takes a double, so that might cause an issue. Return 0. Let's just think about this. So we're expecting a double, but we're putting in an integer. So will it just convert it to a double, i.e. make it 5.0? Let's have a look before he tells us. It just gets 5. So there's no print issue, but it doesn't actually convert to a double, which it should be. Is that because it's a void? Thus, the process of converting data type from one type to another is called type conversion. Thus, in an int argument, 5 will be converted to... Okay. 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 When the compiler does data type conversion on our behalf without asking, we call it implicit type conversion. So copy that. How's the stream looking, by the way? Just okay, all good. Stream is healthy. Yeah. Okay, let's continue. The above example illustrates this. Nowhere do we explicitly tell the compiler to convert. Rather, the function is expecting a double value and we pass in an integer argument. Yes. The compiler will notice the mismatch and implicitly convert into a double. Here's an example where argument is an int variable instead of a literal. Oh, did I? Okay, yeah. So we're setting y as an integer. Yes, and then we're printing y within that, and it will work identically. Type conversion of a value produces a value type, a new value. So the type conversion process does not modify the value or object supplying the data to be converted. Instead, the conversion process uses that data as input and produces the converted result. Produces a new value. Type conversion of a value produces, okay. Type conversion does not modify the value. Instead, okay. So it does what it says. It converts it, and then as a result, because of the conversion, it creates a new value. In the above example, the conversion does not change the variable y from an integer to a double, or the value of y. Instead, the conversion principle is a temporary object. This temporary object is then passed into the print. Okay. Implicit conversion types. Conversion warnings. Implicit type conversion warnings. Although implicit, um, although implicit type conversions is sufficient in most cases, um, consider the following program. So we have a void return type with print and a parameter of integer, and then we produce a print of that. We then print that. Warning, we are passing in a double value, yes. In this program, we've changed print to an integer, and then call the function with a double. So does that mean it's going to go to 5? Similar to the above, the compiler will implicitly convert our double value into an integer, so it can be passed into print. So I assume that means we print out 5, correct? Stream void print, and we want an integer in the parameter, and we will do character output of x with a line break, and then a return type of integer for our main function, and then we will print 5.5, and then we will return 0. So I assume that means, and we'll just clear the terminal, that it will go to 5, and I'll just narrow down like an integer. 5, yeah. But we get a warning from our compiler saying, there we go. We get a warning saying implicit conversion from double to integer changes 5.5 to 5. So if you're on VSCode, you'll get a warning here, but your code will still run. Cool. Such as the following code will, I think the term is narrow down or something, the double to an integer like we need in the parameter and the argument when calling said function. Get that, we'll copy that, and then we'll just indent that a bit. Yes, that makes sense. Okay. An introduction to explicit type conversion via the static cast operator. Back to our most recent print example, i.e. this, and you can see we get the error there saying implicit conversion from double to integer changes 5.5 to 5. Because here in our parameter, we're expecting an int, but in our argument, we print 5.5. What if we want to intentionally pass a double value, turning off treat warning as errors? C++ supports second method for type conversion called explicit type conversion. Explicit type conversion via the static cast operator. Cool. Explicit type conversion allows the programmer to tell the compiler to convert one type to another. and we take responsibility for the conversion. Makes sense? To perform, we use this, we use static cast. And the syntax for this is static cast new type expression. Yeah, static type. So let's update it with that. So to get rid of this warning, we would get rid of that print, and we will call it again, and then we will create some space. Static cast, as you can see there, we get it. Then we have what we want to convert it to, i.e. integer, and then we have 5.5. So convert this double into an integer. Such as convert the double, i.e. the expression, into an integer, i.e. the new type. And then we'll do print, and then what was it? Static type with snake casting, and then we want the integer, and then brackets 5.5. It's snake case, not snake type. Yeah, and that'll work. He says it will work. What is that? Why is that there? Well, we've just static cast integer 5.5. That's implicit conversion now. Maybe if we run it, it'll actually get rid of it. Yeah, it does. So we get 5. Let me just clear the terminal and run that again. And there we go. We don't get any errors because we've used static cast, sorry. Because we're now explicitly requesting the double to be converted, the compiler will not get any errors, as we can see here. Build finished successfully. Starting build, build finished. Cool. Static cast to convert a char into an integer. Last lesson we saw that so 97 prints whatever the code for 97 is. So A. What if we want to print an integral? So we get rid of that. And then we'll delete all this. If you want to, you just basically do the same. So you convert, so you have ch, if we want to print an integral value instead of a char, yeah. So the thing that we the new type is what we want to, so we want to convert a character to an integer. So the new type is what we want to focus on. And I just want to do that. So return type of integer from main, and then we'll do char ch 97, and then we'll do standard character output of ch, and then space has a value, and then we'll do static cast type into hang on, I'll be down in I'll just be right back. I need to go and do something. All right, see you later. And we're back. So I just had to go and do something. So how are we looking? We still good? Yeah, looks like it. Um, Needs to go on charge. Okay, okay. Just give me a second. Okay, right. Sorry about that. We're all good now. Where were we? We were on static types casts. So we wanted to convert a character into an integer, i.e. this into an integer. So we needed a static cast. We want to convert it into an integer. Then we want to call the character a ch, and then the syntax for finishing it is just another one of the no. Yeah, that would be it, right? And then we can always have a line break, and then return 0, and we should get 97 has the value of, or sorry, A has the 97 value of 97. Cool, nice. I was trying to do it without looking at the screen just to get it into my head better. Okay. It's worth noting that the static argument evaluates as an expression. The variable itself is not affected as it creates a new type rather than a temporary type. Yes, that makes sense. So, and then this here. Okay. Sign conversions using static casts. Using static cast. Oh, something happened. Something's happened. Are we still good? Is the stream down? Sorry, my stream just went blank for a second there. We still good? My recording's all good. Yeah, okay, we're still fine. Just a little glitch on YouTube's point of view. Right. Sign conversions using static cast. And then we'll just copy and paste that. Signed integral values can be converted into unassigned and vice versa using static cast. Okay, so remember also last time when we were doing signed integers and unsigned integers, if you add, multiply, divide, or subtract a signed integer with an unsigned integer, that signed integer will become an unsigned. So I'm guessing you can use static cast to convert and make sure that doesn't happen. Again, I believe we did that in the last stream, so go and check that out. If the value being converted can be represented in the destination type, the converted value will remain unchanged. So we have an unassigned integer of u1. We want to convert that integer into a signed integer. Then we print out 5. Then we create s2 being 5. And then we want to create that s2 5 being unassigned. Yes. So if the destination type is unsigned, the value of the module rept, the value will be the module rept. Yes. I.e. the remainder. If the destination is signed, the value will be the information defined. So here we have an integer of s minus 1, which means we're creating a signed integer. And we have an std character output, and we're converting it with static cast to be an unsigned integer, which prints 4 billion, because as we learned last time, the range for an integer is that, especially if it's 32-bit. Then we have an unassigned value of that, and we're converting it from unassigned to an integer, and that will produce -1, because remember, here we're converting it to unassigned, and unassigned is from 0 to whatever the range is. But a signed integer is from -2 to the power of n minus 1 to 2 to the power of n minus 1 minus 1. What I'm referring to is this formula here. This. So this is for signed integers, and this is for unsigned integers. Did I make a note there? Yeah. So because on most compilers, your integer is unassigned, or is signed, and is actually 32-bit, you get that range. But unassigned, I didn't make a note of. But anyway, unassigned has a different range, and that's why you get this value here. And it's different because, where's the formula that I was just looking at? Because signed is this, but unassigned is 2 to the power of n, and then you minus that -1, whereas it's 2 to the power of n minus 1 to 2 to the power of n minus 1, and then you minus that by 1. Hopefully that makes sense. If not, go and check out previous streams or the lessons on this website. By the way, I'm not sponsored by this website. I'm just using this as, I saw this as a good tool. Cool. So such as the following example. And because it's a new concept, i.e. static type to me, I'm going to copy it out. So we got include IO stream, include IO stream with a return type of integer for our main, and then we want an unsigned int of, no, what we actually want is a signed integer of -1. Then we want a standard character output of, and then we're converting it to convert the signed integer to a unsigned integer. So we use the static type for that, which is the following: static, not static type, static cast, and we're converting it to an unsigned integer, and the expression will be, that needs to be x, doesn't it? X. And then we'll have a line break. It's complaining why. What am I doing wrong? IO stream, maybe? IO stream isn't spelled correctly. IO stream. Character output. Standard character output. Static cast unassigned. Character output is undefined. The out. Did you mean ST? Yes, I did, but I'm literally doing that. STD. Am I tripping here, or is this has to be VSCode, right? I think it's a VSCode issue. Hello world. Return 0. It was just bugging, I guess. That was weird. Anyway, um, again, I might have to look at a new IDE after I've learned C++ properly. Depends on what other IDEs are available. So anyway, let's continue. So we got a signed character of S, and we'll do -1. Then we'll do a standard character output of, and then we'll call static cast, and we want to convert the signed integer into an unsigned integer, and then we will be calling S, and then we'll do a line break. Okay, so it was just a temporary glitch. So then we have an unsigned integer rather, and we'll do U, and then we'll copy and paste that. And then we will do a print of static cast, and we will be converting the unsigned integer into an integer. And then we'll be passing in the expression of U, and then we will have a line break, and then we will return 0. And then that should be all good. As you can see there, we get that value and that value as per this. Now, okay, cool. Signed value of integer cannot be represented by unassigned. The module wraps, yes. Unassigned value. Okay. Standard int 8 and standard un8 are likely to behave more like chars instead of integers. So standard input. That's because they have 8 bytes, I assume. Okay. Write a short program where the user is asked to enter a single character, print the value of the character and its code using static cast. So the program should match the following. Okay, let's give that a go. So I'll do include IOStream, then we'll have a return type of integer for our main function, and then we will have so enter a single character. So we'll have char ch unassigned for now, and then we'll have a print of please enter a single character. And then we will have somewhere later on, we'll have a standard character output of you entered, and here we'll do the static cast. So we want to ask the programmer to enter a character, but we want to convert it into an integer and ch, and then a line break, and then, sorry, a line break here, a line break here. I don't think that's the proper way to do that at the moment. So we have a character, we have a standard character output of please enter a single character. We then need the user to enter a single character, ch. Then once the user has entered ch, sorry, you entered uh, which which has the ASCII code of no. So what we actually want to do is we're entering the character here, and then here is where we want the static type. No? So static cast, and then the type we want to convert to is an integer, and then the expression is the ch. Correct. So it's a bit. There you go. So it would be something like that, wouldn't it? So you got the character unassigned. You're please entering a single character. The user enters a character. We then have a character output of you entered ch, which is a character, which is the and then we're converting that character to an integer. So let's give it a go and let's see how we do. Please enter a character a, which is a there, and we should get 97. Cool. And then we just need a space, obviously. And then what we can do is, like the example, we can do a full stop just to make it exactly like this. So please enter a character. For example, let's do B, and then you entered B, which is the ASCII code of 98. So we set the character and unassigned. We produced a character output of what we want the user to enter. We allowed the user to enter. We then had character output of you entered the ch, which is the code of, and then we use static cast, and then we converted the type. Is that the right word? Type. We converted the type, yeah, the new type, and then the expression of ch. Cool. Let's see if there's any possible way to improve that. No, exactly how I did it. So now modify the program you wrote in quiz 1 to use implicit rather than static. How many different ways can you think to do this? Note you favor explicit conversions over implicit, so don't use them in your Ruby program. So the one way I would think of doing this is I would create a void function to pass in a character, and then you would print. Sorry, you would do a void. Enough talking. Let's just try it. So what I'll do is I'll comment that out, or instead of commenting it out, to practice we can do if 0 and end if, and that will just blur it out. So what I'll do is perhaps void print, and in our print we're expecting an integer, because we want to convert the character into an integer. Then we would what? Let's just do implicit. Implicit, just to avoid any naming difficulties. So we'll do character of ch unassigned, standard character output, please enter a single character. Then we want the character input from the user of ch. Then we'll have a standard character output of no. What we'll do then in our main, leaving that as the previous example, we'll do int main, and we'll do standard character output, although that's a void though, and we can't do void within a standard character output. So what we'll do instead is we will do implicit, and then we'll do how about instead of void, we do that, and then we do return ch int x equals the calling of implicit. What if we get rid of that actually and replace it with void, and then we call implicit return ch, and we actually make that integer, and then we make it integer equals x. Then we can do standard character output of you entered x, but we have implicitly converted this to, and then x, and then a line break. Is that how you would do it? Well, let's have a look if it works. Enter a character A. Yeah, cool. I wonder if there's an easier way to do that. So we got, or a better way rather, to do it. So we got an integer. I think that's fine. Just a space there. x. Whereas if we had kept that as void, we wouldn't be able to call x. Let's see. Return C, yeah. Yeah. Yeah, so we could have done, so we essentially just did a different version to this, but we could have just done char C. Okay, that makes reasonable sense. How are we looking on the stream? Still good. Okay, we're still live. Nice. So, chapter 4, summary and quiz. Whilst being sold some Tupperware, some kitchen. Okay, so and then again, like I've done previously, I won't do the whole summary on learncpp.com for X. So the smallest bit of memory is a binary digit, also known as a bit. And then a byte is made up of 8 bits. A data type tells a computer how to interpret context. Void is used to indicate no type. I just want to change that just to make it easier. Void is used to indicate no type. Yeah, different types take different types of memory or different amounts of memory. The size of operator can be used to return size of types in bytes. Signed integers go from negative to positive in the range, and unassigned go from 0 to whatever their uppermost range is. Fixed width integers can include fast and least. Size underscore t is an unsigned integer type. Scientific notation, i.e. the moving of the decimal points and to the left or to the right. Floating points, i.e. doubles, float, double, long double. A Boolean, true or false. If statements, whereas the first line, if, is if it's true, then run this code, and then we can have if else, i.e. if the first line is not true, then we can then we go on to else if, and then if all of the above are not true, we can simply return to else, i.e. the false. A char, and we can convert it via static cast. Okay, let's give the quiz time a go. Pick an appropriate data type for the variable in each of the following situations. Be as specific as possible. If the answer is an integer, pick int. If size isn't important, or specific with integer, okay. So the age of the user, assume type isn't important. So I would go with int. Cool. Whether the user wants to whether the user wants the application to check for updates. Boolean, because we're checking if it's true or not. Yeah, cool. Pi, so that would be a double, but we would use scientific notation, and we would use a double. I don't think we would use a double, possibly. Yeah, just a double. The number of pages on a textbook, integer. Yep, cool. The length of a couch in feet, a float. Yeah. How many times you've blinked since you were born? The answer is millions. So we would do a lot, a long or a long. Perhaps long would be best, although you'd be wasting memory. So I'm going to go with long. Oh no, standard and should T. Okay. The user selecting an option for a menu by letter, char. The year someone was born, integer, or STD. Okay. You could use STD as you have positive AD. Okay, that makes sense. Okay. These quizzes will ask you about multiple concepts that have been presented throughout the lesson. Okay, so things are getting interesting now. You should be prepared to spend some time with these problems. The goal is to help you find out what you know and what you don't know. Don't try to write the solution in one space. Write one function, test if it works, then proceed. Use the debugger to see if it goes wrong. Go back and review quizzes from previous lessons. Okay. If you're feeling stuck, feel free to look at the solution, but take your time and make sure you understand. Yes, because that is the main thing here. The whole point of this is to see if I actually learn and understand. So what I'm actually going to do is I'm not going to take a look at the answers. I'm going to go and take a quick break. The time is 11:30, and I'll be back in a minute. Okay, let's give a go of these questions. Are we still, can I still be heard? Yeah, good. Right, question 2. Write a program that asks the user to enter 2 floating points. So I'll actually just, for now, we'll just get rid of that. Include IO stream. We will obviously have a main function with a return type of 0. So what we'll do, so ask the user to enter 2 doubles. The user is then asked to enter one of the following mathematical symbols. If the user enters an invalid, it should print nothing. Okay, so let's just go step by step. So what we'll do is we'll create a integer. We'll create a function, which will be a return type of integer for now, of user input, and then we will have a parameter of integer. First of all, we will ask the user to, no, it'll be a double because we want a double. So we'll do enter a double value, and then if they don't know what a double value is, we'll do aka a decimal point. Then what we'll do is we will do a double, or rather a float, because a float is smaller. A float of, let's do ft and make it unassigned, and we need to do that. We will then do a standard character input of said ft, and we will return ft. What we'll do then actually is we will do standard standard character output of you have entered ft, and then we'll do a full stop and a line break. Then what we'll do is in our main we will set float x being equal to no, what I decided is I'll get rid of that first. Float x, which will be a user input, and then we'll do float y, and that will be another user input. Then what we'll do is we'll have a standard character output, forgetting semicolon there, and we'll have a you entered x and y, and then so we're just doing this just to make sure that the program works up to this point. So I'll clear my terminal and then run the code, and we get errors straight away. Perfect. Show errors. So what have I done wrong? Float user input. So perhaps that should be void then. No, still not. Maybe then we need to have a int and then a float x. So it actually should be a double. Ask the user to just use double, and then we'll do that. No, sorry, I know what to do now. We'll get rid of that. I've just seen it, I think. And then we'll do we'll do we will do a double x and a double of y. Then we will call user, no, we'll do x double x is user input x. No. Double x and like that. And then here will be user input x. And then we'll have a double y. Double? Will that fix it? User input y. So what if we created a void instead? But then that wouldn't work. And then we get rid of that. And then here we did we got rid of the parameters perhaps, and then we just did user input user input. What about if we change it to integer? And then we get rid of this x. And then we get rid of that for y. Okay, I think we're still causing issues, isn't it? Because we need a return type. Yeah? No, still errors. Ah. We need to convert it using static type, as we have here. So if we then got rid of this, actually, double x, double y, and then we had static cast. No. We did int, and we did int. Get rid of that at the moment. We did int x and int y. And then here we did static cast, and we're converting the integer of x and y into a double, and then we're passing in the argument of x. Then if we do the same here, we do the static cast of double, and we want to, just so it's easier to read, we want to convert it, we want to have the expression of y. We're getting an issue there now. You entered 0 and 0. We never actually got a chance to enter though. So does that mean we need to do user input to allow the user to actually input? Enter a double. Let's do 1.2. But we need to call it twice. Double FT. You have entered, so it's running once. So double FT here, and then we'll do a standard character output of enter another one, and then we'll create a double FT 1, and then we'll do a standard character output of ft1. You have entered there. And ft1. It's probably not the best way to do it, but let's see if it actually works. 1.2, 1.2. You have entered 1.2 and 1.2. Okay, so now what we want to do is if we get here for now, after this, let's do standard character output. Please enter one of the following, and then we'll do plus, minus, times, divide, and then the user will enter what they want. So we'll create a character called input, or operator rather, probably would be best. Operator, and then we'll do that. Then we'll allow the user to enter said operator. Operator. Char input maybe instead. Yeah. So we can't use, I assume operator is a keyword. That's why we can't use it. So, and then we want to say std character output. You have entered input, and then we'll have a line break. So let's just make sure that part works. Let's do 3.14 and 1.2. You've entered 3.14 and enter a double value. So it's repeating itself again. So why are we repeating ourselves again? Is it because of this? I think so. So let's just clear, and let's run it again. Just checking how we are on the stream. Okay, we're still all good. We're still working. So let's run that. Enter 3.14. But then that doesn't run then. So something is going wrong here. Enter a double. Is it because you haven't, and then we're calling it again? So we're calling it again. Let's just do the same. I know it's not right. And then we'll do. So now what I want to do is perhaps uh, I want to convert the symbols from the ASCII, and I want to convert them into um, and I want to convert them into uh, functions, and then so you have entered that. Then std character output. So x symbol y is, and then we would have my result here. Then we would have a line break, and then we'll run that again. So 1.2, 1.1, 1.1, I need to sort out this double. So there. You have entered there. One symbol, one. So what we'll actually do is we'll get rid of symbol and we'll do input. And then we'll clear this. We'll then run it again. We'll do 1.1, 1.1, and annoyingly it does it again. We'll do times this time. 1 times 1 is that. So what we can then do is we could do an if statement to show that or to get the if the user enters this, then that means we times it or multiply it or add it. And then we would, in our if statements, do. So let's just do it in main for now. So if then the condition of input is exactly equal to the string of plus, then we will do x plus, no spotlight, x plus y. Else, if input is exactly equal to minus, we need a semicolon, that's why it's causing an issue there. We will do x minus y. Else, if input equals, let's do times, we will do x times y, semicolon. Then if we do else, if input is exactly equal to divide, we will do x divided by y. Else, and then we'll do else return please enter a valid else return false. Let's do instead. Then what we'll do is if input equals but then there's no way of converting that, is there? What we need to do is we need to create a sum, don't we? Okay. X input Y, and then we need to convert that into a result, don't we? If X plus Y, else if I think I'm going to need a hint. Write 3 functions, one to get a double value, one to get arithmetic, one to calculate the answer. Use if statements, operator equals, that's what I did, what I've done. Consider using an early return. So return that like that. Return x equals y. Return x equals y. And then return x divided by y. So what we'll do is we will put that in a we'll put that in a function for now, just to make main a bit less cramped. So we'll do we'll do a boolean of symbol, and then we'll just copy and paste this. Int input, maybe something like that. No, let's no, because what we really want is we want to return a character. So boolean symbol character x character y. Then we pass in all of this. And then if we did car input, that would sort that out. I don't think then we actually need that. Yes, we do. So we have a int x, int y. Then here we want to return true. Then we want to, in here, print the symbol we want to call symbol we want to call symbol XY. Would that actually work though? That's the thing. We got the input there. We got symbol X and Y. No. Yeah, because we're adding we're getting the input we're getting the character input. Let's have a go at that. I don't think it will work, but let's give it a go. 1.1, 1.1, and again it's annoying. It does it twice. Enter. So 1.1 plus 1.1, we should get 2.2. 0. So we're getting a 0, which means we need to convert. We need to use static cast, I assume. So static cast, and we want to create an integer from our symbol X, Y. Is that valid syntax? Let's run that again. 1.1, 1.1, and annoyingly it repeats it again. You've entered that, so 1.1 plus 1.1, do we get 2.2? You got 0. So we're actually, what we're finding here is we're having 1.1 and 1.1, but we're actually getting 1. So it means here we actually need a static cast again, and we want to convert it into a double of X. And then here we want a static cast of double, and then we want Y. Let's just make that a bit longer. So we got a static cast, we've got a new type of a double because our X is set as integer, because our user input is an integer. We're then converting it to a double, and we're using the expression of X. We've then got the input here, i.e. one of these, which is a character. We've then got the static cast, and we're creating a double from Y. And then we do a static cast of int, because we want to change the Boolean of symbol into an integer, which should hopefully produce that. No, surely we want a double. I just realized that. So let's, how are we looking on the stream? Still good? Yeah, we're still good. So let's give that a go. Actually, I want to just, I'll cancel out that. I want to come out of this. And we'll run it again on a clean terminal. So running, and we'll do 1.1, 1.1. Again, the annoying one is 1.1. Then we'll do plus. 1 plus 1 is still 0. One plus 1 is still 0. Do we do static cast in here? in the Boolean. So first of all, before we even look at the answer, let's actually create the third function of calculate ans of calculate answer. And then in this we would definitely have an integer of x and an integer of y. And we will want to, maybe here is where we do it, where we do all this. If sum, so we create maybe an integer of sum, and we do x plus y, x plus y. And then here we would do this. We do basically the same. Sort of. But then we don't have input. Sum of, no. We need an integer of sum, and then we need we could call the symbol in this, but then I think that's getting too complicated. I think that is the duplicate error issue. So I was just thinking of something else. So let's see if that got rid of that. No. I think here, static cast, and we want to convert it to a double, aka ft, and then a static cast, and then we want a double of ft1. Possibly. Let me just clear that. See, I would like to not actually look at the answer. I would like to prefer to do it myself. What if we did instead, but then we would need to do that might actually fix it. If we did a integer of x and an integer of y. Then we can get rid of this. We can then do x here. We can then get rid of this. We can then do y here. We can then do x here, converting it into a double. And then we return return x and y like that. Is that valid syntax? Yes. So then in here, we can actually just have the input result, get rid of that, and here we do x and y. No. Because we still need x and y. Let's see if that does anything for us. So I'm getting a warning error. Yeah, it's not valid. I didn't think it was valid syntax. I am stuck at the moment. I think I'll have a look at the solution, to be honest. So we got a double of get double. We got a char of, so not even close. Sort of close here, but that should have been a char. Get offer, no, this should have been void. So double char, okay, passing in 2. And we don't need that. A double of x, a char of operation, and then a double of y. Then we have a double result. And then we have a double of result, which is empty, so sort of right there. Then we call the operation for all of them, whereas it was input. Then we want, okay, result. And we just return. But then our x isn't working there. So result equal, because we need to assign it. We need to create the initialization. Okay. So that I was sort of close on, but I wasn't actually closer when you think about it. So what we did was we did a void. We did double X. We did the character of operation, and then double Y in our parameters. And then we did the early return here. So that was the result. So we don't actually need that now. Then what we need to do is we need to get the operator. Okay, so user input. So double user input. We don't pass in any parameters. We do the std character output. Then we do a double of x. Then we call x. Okay, so we don't need any of this. And that makes sense, and I should have realized that because we'll be calling, I assume, user input twice. Yeah, we'll be doing get double twice. So when you call get double twice, when you call it twice, that was why we were getting it twice, because we entered it twice. So the function was running, then we needed to run it again. Return, and then return x. And as a result, we don't actually need this. And that's a lot more simpler and a lot more easier. Should have realized that. So then we're having, so then without looking at the get operator, we will do char get operator, and then we will have std character output, but this is the easy bit. Enter an operator, and then it's either plus, minus, times, or divide. Then we want the user, we want a char of symbol, and that will be unassigned. Then we want the user to enter said symbol, and then we return symbol. Return symbol. Correct? Return operation, yeah. So instead of operation, instead of symbol, they've used operation. So I'm still getting that issue. Double x, sin x, return. Why is that not okay? Oh, it's still thinking I have a comma on my mistake. So user input. So I need to remember that because we'll be the function will we only need to enter it once, and then we can call the function as many times as possible. That's why we don't need enter double value twice. Here is straightforward, and here I need to remember to add the parameters that I want. I was sort of close here because I had input originally. So now in our main, if we get rid of all of this, so first of all, we want to ask the user for input. So we'll do a double x and we'll call, again, I'm not looking at the answer for main, user input. And then we'll have a double of y for user input. Okay. And then we need semicolons, obviously. Then, so we're calling user input. So let's just run that. Close that. I want to clear that. I want to actually then open a new terminal instead. Let's get rid of that. We'll run it again. It's all good. Enter a double value, 1.1. Enter a double value, 1.1. So we've got that. So now we can move on to the character output of you have entered X and Y. I know this is not what it does, but I just want to make sure that it works. And Y. So do that. We'll do a line break and we'll make sure that that works. So enter a value, 1.1, 1.1. You have entered a 1.1. Okay, good. So at least that's running. So, so we've got that. Now, we need to get the operator. So what we'll do is we'll do char symbol, and then we'll call get operator. Correct? And then we need semicolon. You have entered the. So now what we'll do is we'll do std character output, and we'll do symbol. Or to make the code better, can't we just get rid of that? Because char get operator is already a I think there's just an issue with YouTube. Yeah, there we go. Okay, good. Yeah, because my stream went down for a second there. Okay, so we don't actually need to call. We don't actually need to create a. We don't actually need to create a variable for get operator, because our get operator is already a char. So we can just call get operator, no? And then that will print that. Standard character output, get operator. No. Yeah. Then, so enter operator, char symbol, return symbol. And then if we run that, 1.1, 1.1, we got that. So then, what we actually probably could do is we could standard character output, enter an operator, then we need to do the sum, i.e. the result, So we would do no, in that case I've just seen I think perhaps a symbol variable would be best. So we'll do a char of symbol and we'll initialize it, yeah, with get operator. Then, let me just get rid of that for now. You have chosen, and then symbol, and then full stop, and a line break. So let's now, that's why it's complaining, because we need that. So now what we'll do is we will, let's give that a run, clear the terminal, enter a double value 1.1, 1.1, plus you have entered 1.1 and chosen to add. So then what we can do is we can do double result, and then we're calling print result, and then within our print result we need 3 arguments. So we would do x symbol, yeah, y. Possibly changing that to static cast char symbol. No. Yeah, because as it says, our print result is void. So that means, can we just do this? X space symbol is X space symbol y y y is, and then print result, but then that's going to throw up complaints because X no, actually it won't. Symbol y, but that's the issue though. Print result is void, so so is this where we use static void, static cast, and then we make it a double, and then we pass in, but then we're still passing in print result. X symbol y. Yeah. is this. So then we can run that. 1, 1, 1, 1 is this. So we're still getting that. So now we just need to create the result. Now the result surely the issue is that I see what I missed out. And again, it comes back to this pesky void print result. I simply did not include this. But then we still need to call get operator. Sorry, print result in our main. No, because then we don't need idiot. That makes total sense. This should be not this. This should be in here. It should be, because we know from previous times we cannot pass in void functions. So that makes it so much easier. So because we cannot pass in void functions, we then need to adjust the void functions accordingly. So we'll do x. That's why we pass in the parameters. Unbelievable. X and then operation. I don't want to look because I want to learn X operation, but I think perhaps we should do that, and then that, and then Y. That makes so much more sense. I've done void functions before, and I should have realized that. X operation Y is, and then we pass in the result, and then as a result, yeah. Now as a result, we can get rid of this, and surely we can just print result, and then we need to pass in the arguments symbol Y, and then surely it works. So because this function of print result is void, we cannot pass it in to something like a std character output in main. So as a result, we need to print the output in this function. That makes so much more sense. Should have realized that, man. So now he says, are we still good on the stream? Yes, we are. Okay, cool. So now that I should have realized. We call this function twice, therefore there is no need to ask the user to enter the double twice. So I'm glad I got that if statement logic roughly right. Logic for seeing what the user enters for their symbol, and then an early return. Oh, I should have realized that. Okay. So now we should find that we actually get our result, no? So compiles all fine, 1.1 plus 1.1. Now we do times, add, sorry. So 1.1 plus 1.1, we should get the magic value of 2.2. Perfect. We could probably also get rid of this, to be honest. So now let's test. So we've done plus. Now let's do 1.1, 1.1. Let's do minus. And we get 0, correct? Clear. Now let's do, hang on. Now let's do, so we did plus, minus, and now let's do equals. Plus, and we can't do equals. Let's do times. 1.1 times 1.1 is 1.21. I don't actually know the value of 1.1 times 1.1. So let's just check that's right. 1.21, correct. And divided by is just 1 because you're dividing it by yourself. That makes sense. So let's just test that our program actually works. So I'll do clear. We'll do run. We'll do 1.1, 1.1, and we'll do divisible by. Okay. Perhaps now I want to check. What if someone just did this? So at least we know. Or what if someone did this? Okay, so what you could potentially do is else return, please enter a valid operator. No. What we'll do instead is let's do now we need to do string, don't we? Else return standard character output, maybe? No, I didn't think so. What I'm basically trying to do and thinking of is if the user enters something else, we need to say that's wrong. But I think I'll leave that for now. Hopefully you understand what I mean. Okay. I think what I'll do is I will do I will do this extra credit one off camera or off stream, and then because I want to move on to the next variable, the next lesson. But what we could do then is write a short program to simulate a ball being dropped from the tower. So because I'll do it off stream, let's briefly go over it. To start, the user should ask for the height of the tower. Assume gravity is that, and the ball has no initial velocity. The ball is not moving to start. Yes. Have a program output the height of the ball above the ground after 0, 1, 2, 3, 4. This is actually interesting, so maybe I will do it on stream. The ball should not go underneath the ground. Height 1. Use a function to calculate the height of the ball after x seconds. This function should calculate how far the ball has fallen after x seconds with the formula distance fallen equals gravity times x to the power of 2 divided by 2. So enter the height of the tower in meters at 0 seconds. Note, depending on the height of the tower, the ball may not reach the ground in 5 seconds. That's okay. We'll improve the program once we cover loops. So because we're covering this in loops, I think I should do this on stream, to be honest. So the time is about 1. So what I'll do is I'll take a quick break, and then I'll try and do this for about half an hour, and we'll see where we are. And obviously, if we get stuck, we'll show the solution, and then if we're going through the solution, it's best just to scroll down just so you learn. So I know I don't typically do this for questions, but I want to copy and paste this into my notes. Questions 1, and then the question was this. And then I will indent my code a little bit, just to make it obvious. Okay, I will be back in a minute. So let's give this a go. What I want to do first is I will do the Git repo. Um, for this topic, or for this lesson, or this lesson we did. So what did we do? So day 8, we covered chars. And then we initialized chars. Initializing chars. Extracting white spaces. Extracting white spaces, chars, and chars meaning characters. Escape sequences. Escape sequences. Implicit type conversion, implicit and explicit. Explicit type conversions, i.e. Static. With static cast later actually. Static cast. New type expression. Yeah. Tutto bene. And the date is the 5th of August. Okay, so let's give this question a go. We've got a copy of that, so we delete that. So what do we want to do? So we want to simulate a ball being dropped off a tower. We want to ask the user for the height of said tower. Then we want to calculate gravity, the ball, the initial velocity or speed, velocity / speed of the ball should be 0. Makes sense. We want to output the height of the ball after 0, 1, 2, 3, etc. seconds. and the ball should not go below the ground, aka it's 0. So we want to create a function to calculate the ball after X seconds. So let's do that. I think we'll use a double perhaps. No, what did we use last time to calculate? We used void. And then maybe in here we pass in so because he said we'll cover loops, we won't do 4 loops at the moment. We'll just do 1, 2, 3, 4, 5 with no 4 loops at the moment. The function can calculate after X seconds. The function can calculate how far the ball has fallen after X seconds using the formula of distance fallen equals gravity on constant times X seconds to the power of 2 divided by 2. And then we should expect this. Okay. Where do we begin with this one then? So first of all, we'll need a function to calculate. We'll need a function for getting the user input, first of all, and then we'll need a function for main. So let's just do the main first, because we know what's going to happen there. We'll do the standard return 0. And then above this, we will, let's have a look at our last example. So we'll need a user input. We'll do a double. So let's do, first of all, we need to include input-output stream. Include input-output stream. Then we need a function for the user input for the height of the tower. So which will be a double. No. Yeah, let's make it a double. Double height, double tower height. Let's do that. And then, like we did in our example, we will do std character output enter the height of the tower in meters. Then if in here we did yeah, we did a double. No, we won't do the parameter. We'll do a double of we will do a double of x, and then we'll ask the user for the input x, and we need to finish off both of those with semicolons, and then x, and then we will return simply x. Cool, so that should be okay, good, 25 minutes, we've got plenty of time. That should roughly be what we want to do. So let's just test that that works. So I want to clear that. And then I want to, what do I want to do? I want to, we're still good? Are we still alive? Yeah, we're still alive. Good. I want to test that this works. So to do this, we just print tower height, don't we? Like we did in the last one. Or no. Let's do a double x, double tower height, and then we call tower height, and then std. No. For the time being, surely we just do tower height, and then that'll be it, and then that'll call. So let's do that. Enter the tower height in meters. Let's do 100. And then what we'll do is we'll do a standard character output of the tower height has been set to x. Just double check that. 100, the tower height has been set to 100. Nice. So we've done the ask the user for the height. Perfect. Now we need to calculate gravity, which will be the difficult bit. So we'll need a function for no, we need a function to calculate height. So like we did in the last one, let's create a void function to print result. A void, and because we're doing a void to print ball height. So within print ball height, we will need an integer for seconds, integer for seconds. We will need a double for meters. Why is that not playing ball? Oh, it is now. Okay. So um, we need a double for meters. And then say if if meters no, let's do a double for result, a double for height of ball. Then what we'll do is if height of ball is exactly equal to, because this is interesting because it's game mechanics, and that's one of the main reasons why I want to learn C++. So if height of ball equals 0, then return. And then, like we did here, then say, no. Let's do a proper if statement, statement logic. How are we looking on time? 20 minutes, okay. So if height of ball is equal to 5, we will return no, stop. Okay. No. We'll do gravity as well. We'll do a double of gravity, and we will initialize that with use a function to calculate the height of the ball. The function should calculate how far the ball has fallen after X seconds using the following formula. Distance equals, so distance fallen, so maybe that should be distance fallen, and then we will set so if we do a double of meters, so assume normal gravity is that. So surely if we just did double gravity is 9.8. So then we do double perhaps of height equals gravity times x seconds times seconds to the power of 2, and then to the power of 2 divided by 2. Well, I don't feel like that is correct. I would perhaps prefer to do direct listing instead. Maybe that's better. So, print ball at height. So then we would do if seconds equals 5, then we do a then we would do no, surely that should be that. We'll get rid of that for now. So we've got a double of gravity, we've got a double of distance fallen, we've got seconds and meters. So if seconds equals 0, then distance fallen equals 0. If seconds equals 1, then distance fallen is equal to distance fallen minus seconds. I don't think that's right. If seconds equals 2, then distance fallen equals I'm a bit unsure, but I'm still going ahead with it. 3 distance fallen equals distance fallen minus seconds. But at least I'm giving it a go. If I know we need an if statement, I know that for a fact. Without having to look at the answer. And then if distance fallen, if seconds equals 5, sorry, that should be else if, shouldn't it? Else return And then here we will do std character output, and when we return, we will get the ball is on the ground. So here we will create the ball is on the ground. So here we will create a double of type like we did here. Double of height, sorry. Double of height is equal to tower height. Then we want a double of seconds to be empty for now. Then if we do std character output, the height of your tower is height, and then we'll do that just to make sure we're still working with the correct outlay. Double equals. Let's just run that again. Cool. 100 meters. The tower height, so in that case, I think we can get rid of that for now. Actually, I want to comment that out just in case because I'll probably get rid of this one first. So let's run that again. We'll do, what if we did that? 0. Okay, good. So at least we know that's working. So, okay, so 10 more minutes on this. So we'll do 100. Your height tower is 100. So what then if we then called print height of the ball, and we need 2 arguments. So we did seconds, and then we did height. What would happen then? Let's have a look. 100 meters, nothing. So nothing actually prints. What if we set let seconds equal to 5? Would that print anything? Okay, so at least we know that our ball is on the ground at 5. What if we did 6? 100 meters. Okay. Yeah, so what if we did 2? I assume nothing would happen at 2. Yeah, so we now have an issue with this, which is what I thought the issue was going to be. So I think I've just done that completely incorrectly. So we need to do the height probably as a double. Let's pass in, no, we'll do height as double. Distance fallen equals gravity which is 9.8. And to begin with, velocity, so we need velocity actually as well. Double velocity so and then so the ball is not moving to start. So if seconds equals 0, distance fallen equals 0. What if we then just did this? STD character output. So at 5 minutes, at can we just do this? Is that possible? Because I know you can do that in other languages. Yes, we can. No, we can't. Expected a statement. So we just do a bunch of if statements? Because what I was thinking is I would just do at seconds the ball is at a height of meters, but that doesn't make any sense. That doesn't seem right to do just if, not else if. So I think I'll get rid of that for now, and I'll return to else if. What about if we did at seconds equals 0? Okay, 4 minutes. What perhaps I will do is we'll see where we are. For now, if we maybe show the solution and then we can discuss it and then see and then we can come back and see just how wrong I am. So let's show the solution and then tomorrow we'll come back to it. So double, get tower height. So this is correct, standard character output, enter the height of the tower in meters. Good. We got a double of X, or they have tower height. We have a character input of good. Okay, good. Print ball height. Okay, so this is where we get a bit messed up. So he's literally calling, so he's not doing anything in main. We got a double of height, tower height, good. So that's correct. We don't have seconds because we're calculating seconds elsewhere. So calculate the ball height, print the ball height. So in print the ball height, we've got a initial of seconds, good. But here we actually have a double of ball height, which is meters, isn't it? Yeah, meters. So that's correct. That's good. Good to know that's exact, right. So uh, if ball height is greater than 0, STD character seconds, the ball is at ball height. Okay. Else, STD character output at seconds, ball is on the ground. So if the ball height is less than 0, so I didn't need all of this. What is on the ground? Then we need another function to calculate the ball height. So at the moment I've put it all into 1, which I shouldn't have been doing. So we got a double of gravity, correct. We got a double of distance fallen, which is gravity times seconds. Seconds to the power 2. Will that work? Anyway, that should be outside. Times seconds. And then we got the ball height here. They haven't got velocity, so that's one thing. And then they've done if ball height return 0.0. They've gotten rid of this. Then we print ball height, which will be this, which is void. Good. We already covered that. Then we calculate ball height with a double of tower height and into seconds. A double of ball height. We're calculating the ball height. We're calling calculate ball height, which is this. We're doing tower height, i.e. this, and seconds this. Then we're printing the ball height in seconds. And then in main, we're calling calculate and print ball height. Okay, I'm going to leave it there because we're at 1:30 now. I'm not going to save in the GitHub for now, in the GitHub repo. And then what we'll do is we'll come back to this and we'll have the solution and I'll go through it to make sure I understand it. Okay, cool. That's going to be it for today. Hopefully you enjoyed. If you did, comment about what you enjoyed and what you liked, and what you thought I did wrong, and when you had a hands in your head moment. Hopefully you enjoyed the questions because they took up a lot more time than I originally thought. And if you followed along with the questions and got them right without having to look at the answers, well done. So as always, please comment, please like, subscribe, and all that good stuff. And I will see you in the next one. Goodbye.